This is Miss Michael, and I'm going to try to be more exciting with my voice because I do realize that this activity is probably not the most exciting, but it is informational. This is the third video of our digital day, and there are three terms that I would like you all to go ahead and write down. They're right in front of you in bold. We're going to be discussing comparative anatomy as evidence of evolution. Now, we've already discussed embryology and we've already discussed the fossil record. The third bit of evidence is these anatomical structures. The first type of structure you need to be familiar with are homologous structures. And again, that root homo means same. So homologous structures show individual variations or differences on a common anatomical theme. They're seen in organisms that are closely related. So these are things that actually look similar in structure, but different in function. So I'm going to go ahead and add that. They're similar in structure, and you should write this too, but different in function. Different in function. Okay? And I'm going to show you some examples of homologous structures in just a moment. So the analogous structures have very different anatomies, but they're similar functions. They're seen in organisms that are not necessarily closely related, but that have lived in similar environments and have similar adaptations. Now, I can give you one of those. That would be a human mouth and a bird's beak. They look very different. A bird's beak looks very different from a human mouth, but they both have the same function. They both have that similar use, and that is based on the environments. Vestigial structures. These are anatomically, they're remnants, which means at one time they were used, but they're no longer used, but they're still present. Okay? Your appendix would be a vestigial organ. That's an example of vestigial structure, of vestigial organ. Your wisdom teeth are vestigial structures. Some people don't even have wisdom teeth, but and some people have wisdom teeth and don't have the actual room for those wisdom teeth to come in. We don't need them, but they're still present. Vestigial structures. In whales have pelvis bones, and obviously a whale does not use that pelvis bone. It's just there. So vestigial structures are structures that are present but are not used. It indicates an organism's common ancestor, meaning, you know, with the whale, that it suggests that perhaps the whale was once a walking, a land animal, a walking mammal, or ancestors of that whale were walking on land. So vestigial structures, analogous structures, homologous structures. You want to go ahead and just write that down in your notebook, and we're going to look at homologous structures in this activity to start. Okay, so these are all homologous structures. You have the human arm, you have the whale fin, you have the crocodile leg, the cat leg, the bird leg, and the bat wing. They all look the same, and that's because they all have these parts. There's a humerus, there's the ulna, there's a radius, you have carpals, you have metacarpals, and phalanges. And so looking at these structures, you can see the humerus on the human arm is here. It's also shaded on all the other structures. The humerus on the whale is right in this area. The humerus on the crocodile is right in this area. The humerus on the cat is going to be this bone. The humerus on the bird is on this bone, and the humerus on the crocodile is on this bone. And if you have colored pencils, you can I think that's what the instructions indicate for you to color code them. So let's say you're using orange for humerus. You can color each humerus by its position in these structures. Okay. The next structure is the ulna, and you can see here, this is the ulna in the human arm. In the whale, your ulna is condensed or a little thicker. Here in the crocodile leg, you can see the ulna depicted right here. Okay, your ulna in the cat arm is right here in this region. Your ulna in the bird leg is going, or the bird wing, I should say, bird wing, pardon me, is right here. This is the ulna. And your ulna is this thin bone in the bat wing. The ulna is right here in the bat. So let's say you use blue for that particular structure. Blue to color in all the ulnas. You can go ahead and color that in. Okay. The next structure we're going to look at is the radius. The radius is very similar to the ulna. It's on opposing sides. Your radius in the human arm is here. Okay. Your radius in the whale is right here. Your radius in the crocodile arm is right here. Radius in the cat leg is going to be located right here, again next to the ulna. Your radius in your bird wing is here, and the radius in the bat wing is this other thin bone opposite side of the ulna. That's the radius. So let's say you color your radius red. Red. Okay. Let's look at the carpals. You have carpals in the human arm in this area. It's pointing to that. Here are your carpals. In the whale, these bones in this section are your carpals. In that area, all those little small bones are carpals. In your crocodile, these are your carpals. These are your carpals. The carpals in the cat are right in this location. You have carpals in the bird wing right here. And you have very small carpals in the crocodile, which if you're coloring those, maybe we'll color those green. The carpals will be green. They're very tiny. You may even just have to draw a line that says these are the carpals because they're so small. Okay. Then you have your metacarpals. You have metacarpals in each structure. So these are your metacarpals, these bones in this region. Okay. Your metacarpals, and they're just attached to your carpals. Okay, maybe you're coloring that purple. Your metacarpals purple. You have metacarpals in this area right here. These small little bones, again, attached to the carpals are metacarpals. Those are, maybe you're making those purple. Your metacarpals in the crocodile are in this region. These bones in this region attached to the carpals. Your metacarpals in the cat leg is here in this region. And your carpals in the bird wing are this region. And then you have your carpals, your metacarpals in this region. Metacarpals are attached to the carpals. Metacarpals, these long thin bones in the bat wing, are your metacarpals attached to those carpals. And then last but not least, you have phalanges. It's such a fun word to say, phalange. It's another way to say fingers. You can use that word. It's synonymous with fingers, typically. Your phalanges are attached to your metacarpals. So the phalange, perhaps you're coloring the phalanges yellow. Your phalanges are these bones in this region on the human arm. Okay, your phalanges on the whale are these bones. Okay, they're these bones. Your phalanges on the crocodile, again, those are attached to the metacarpals. They're going to be yellow phalanges. Your phalanges on the cat leg are here. They're attached to, again, the metacarpals. You have phalanges here in the bird wing. And these bones that are attached to the metacarpals in the bat wing are here. These are your phalanges. So hopefully you've got all of those structures color-coded. If you don't have colored pencils, you could actually just label them. These are anatomical structures. Again, anatomy, structural components. That is a evidence of evolution, another point of proof that organisms are related, the skeletal structures, the comparative anatomy. And these are homologous. These are homologous structures. If you wrote that down, you know that homologous structures, they're similar in the way that they look, but they're all different in function. So we all know the human arm does not function the same way a whale fin does, or a crocodile leg, or a bat wing. They have different functions, but the structures are very similar. Homologous structures. We're going to explore comparative anatomy in another video, but I would like for everybody to go ahead and make sure that you understand that these are homologous structures and the different parts of those structures.